In this video, we're going to go over hyperbolas that are centered at 0, 0 and that have a transverse axis along the y-axis. Now, last video, we went over hyperbolas centered still at 0, 0, but had transverse axis along the x. And so you know the difference when it is along the x-axis, your x variable will be first. So now on these, because my y squared is first, that is how I know that the transverse axis is along the y. So this is kind of the biggest difference between your ellipses and your hyperbola. With your ellipse, your x always came first. What switched was your a squared and your b squared. But now with hyperbola, a squared and b squared do not change places. What changes places is your x squared and your y squared. And on your formula sheet, I do note that. Okay? On your formula sheet, I put that a squared is always the largest of the two numbers. And so that's how you can tell these two apart. That your a squared here is bigger under your x. That's what makes it parallel to the x-axis. And that your a squared here is bigger. And so that's how you know it's parallel to the y, because it's under the y. And then hyperbola, I put here that a squared is always first. So your a squareds are right here the same. And what changed is your y and your x. So going kind of along with that, we know that this is centered at 0, 0, because when it is shifted, you'll have y minus k, and you'll have x minus h. So you'll be adding or subtracting something. So this means my k is 0, so that's why it's y squared, and my h is 0, that's why it's x squared. So if it is just x squared, y squared, that means it's 0. Okay, so because it's y squared, x squared, that's how we know it's centered at 0, 0. The foci and the vertices are still C and A. This formula does not change, so we will use that again to either find B or C. And these will still always be equal to 1. And so when I come over here to look at my example, now that transverse axis is along my y-axis, so now on this y-axis, that's where you will have your two foci, your two vertices, and then the center. My asymptote formula does change. When it is along the x, it is b over a, and now it is a over b. Then everything else is the same. So, example 3, we're analyzing this equation that is finding the center, the transverse axis, vertices, foci, and asymptotes. So, this always needs to equal 1. This does not equal 1. So to get this to equal 1, we need to divide by 36. And if I divide this by 36, I need to divide everything by 36. Now, this is really just reducing your fractions. 9 over 36 is the same as 1/4. 4 over 36 is the same as 1/9. Now, if you don't know how to do that, don't know what I did, you can use your calculator. Okay, if you do 9 divided by 36, you get 0.25. If you go here to math, first one is converting this to a fraction, and we get 1/4. So that's your 1/4. Same thing here, 4 divided by 36 is 0.1 repeating. So go math, change it to a decimal, just hit enter, and that's 1/9. And so that's 1/9. Okay. So from here, we can answer our questions. Now that I have this equation. The center is at 0, 0. And I know that because it's just x squared and it's just y squared. The transverse axis is my y-axis because my y-coordinate is first, and more specifically, that's which one is positive. This one, my x is negative. So I need vertices, foci, and then asymptotes, and we'll graph. So my vertices have to do with my A. And so here, A does not move. A is always first. So it doesn't matter that 9 is bigger. With ellipsis, A is always the bigger. That's not the case here. My A is always first. So here, A squared is 4. So therefore, A is plus or minus 2. So my vertices then and remember, this is along the y. So this is 0, 2, and 0, negative 2. Okay, so that's one of my answers. Making those a little bit more bold because this is technically not an answer. Okay. My foci is my C. I don't have C, I only have A and B. My B here is 9, which means B is plus or minus 3. So I can use this formula to help me find C. So B squared equals C squared minus A squared. B squared's 9. We don't know C squared, and then minus 4 for my A squared. Let's add 4 over to get 13 equals C squared. So C equals plus or minus the square root of 13, which is about 3.6. So my foci are at 0 square root 13 and 0 negative square root 13. And then the last thing we need is our asymptotes. So we have y equals plus or minus a over bx. My a is 2 and my b is 3. So this is plus or minus 2/3 x. Okay, so that's all the information at once. And so now we can graph. So the center is the origin. My vertices are at 0, 2, and 0, negative 2. My foci is at 0 square root 13 and 0 negative square root 13, which is about 3.6. Go up to 3.6, down 3.6. Okay, so those are my 5 points along that transverse axis. And then I will plot my B, which is 3 over and 3 over. So using my B and my 2 vertices, make your box. Sure, that's very annoying to listen to. Okay. So once we make our box, we'll go corner to corner through the center. And these are my asymptotes. So then we'll go from vertice and we will make this thing hug these asymptotes here. So this is a pretty wide hyperbola. Oops, and off the page. Same thing here. Vertice, hug that asymptote. Vertice, hug the asymptote. So my hyperbola is right there in blue. Let's try one more example with a hyperbola centered at 0, 0 and the transverse axis along the y. Example 4. Find the equation of a hyperbola that has one vertex at 0, 3 and foci at 0, -4 and 0, 4. Graph the equation. So let's go ahead and just plot those 3 points. Vertex 0, 3. Foci at 0, -4 and 0, 4. So they do not tell us where the center is, right? But the center is always going to be basically the midpoint between my 2 foci and really between my 2 vertex, but I don't have those. So what's the middle of my 2 foci? And that's right here in the center. So that does mean my vertex, if it's 3 up, we're going to go 3 down here. So that tells me, because my vertex is 3 up and 3 down, that tells me that A is plus or minus 3, which means A is 9. And then my foci is up 4, down 4, so that's C. So C is plus or minus 4, which means that C is 16. Okay, I also know a couple other things here. We have already stated that the center is at the origin. And then we need to figure out where the transverse axis is, because that tells me which of my 2 versions of my formula to use. And that is along my y-axis. So when it is along my y-axis, we will use the formula of y squared over a squared minus x squared over b squared equals 1. So to find this equation, the only things I need are my a squared and my b squared. Well, I do have a squared. These are supposed to be squared. A squared is 9, c squared is 16. Okay, so I do have a squared. A squared's a 9, but I don't have b or b squared. So we will use our formula to find it, which is b squared equals c squared minus a squared. So b squared equals 16 minus 9. My b squared is 7. So I will write my formula now that I have all my information. We have y squared, and by the way, I know I'm using this one, right? Because my transverse axis is my y-axis, so that means my y comes first. I don't think I said that. Y squared over a squared minus x squared over b squared, which we found to be 7, and that equals 1. Okay, so here's my equation. So once we find the equation, then it wants me to graph the equation. Well, I already have quite a bit on here already, just from the information they gave me. So now I need to actually put in my b. So if b squared is 7, that means b equals plus or minus the square root of 7, which we have found in a previous video. which is 2.6. Let me go plus or minus 2.6. So let's put that on our graph. We'll go 2.5 and 2.5. And then we make our box. You make your boxes with the B and with my vertexes. Okay, once you make your box, then you will find your handy dandy ruler, and we will go corner to corner through the center. And again, all of these dashes and me using red, this is not technically part of my shape, right? But it is helping me make the shape of my hyperbola. So then we will go vertex and hug those asymptotes. So vertex, hug the asymptote, vertex, hug the asymptote, vertex, hug it, vertex, hug it. So my hyperbola is right there in blue.